Hello again. We're doing partial fraction decomposition. We did that last time too with distinct linear factors. Well, now what we're doing is repeated linear factors. And all that basically means is this. Before I had like 3 different quantities and it was fine. Repeated linear factors means, well, this is linear, the denominator, but it has an exponent on it. It's like 4 or 2. If you have a quantity that's linear but it has an exponent on top of it, it's just a repeated linear factor. And there is a slightly different approach in order to take. But what you have to make sure to do in order to do partial fraction decomposition is make sure that the degree of the numerator is less than the denominator. Well, this one is x cubed, this one's x, bam, fine. No need to even worry about long division, which is good, to say the least. So what I want to do is I want to figure this out. Now linear factors are pretty interesting. We did that before, we'll kind of do it again. It's just a different approach to it. So here we go. We want to set 2x over x minus 1 cubed, or sorry, quantity cubed, into 3 different fractions. In this particular case, it's 3 different fractions. Well, is it yeah, 3 different fractions because it's to the first, to the second, to the third. And here's how we do it. We repeat the linear factor over and over again. So the first one is x minus 1 to the first. And you don't need to put x minus 1 to the first. Next one is x minus 1 to the second. And the last one is x minus 1 to the third. I don't know what the numerator is on any of them, so what I do is I put a, because a goes first, I'll put b, and I'll put c. That's really all there is to it. I probably didn't explain this as well as I wanted to on the previous lesson because I didn't have any room. I guess maybe I have a little bit of room, so I'll go ahead and show it now. What I want to do is I want to get rid of the denominators. This problem is already terrible enough, and I don't want to work with the denominators in order to figure out my a, b, and c. So what I do is I basically multiply the whole equation by whatever this denominator is, and it's x minus 1 cubed. So I'm going to do that for each term. Now what happens is that the denominators will cancel out here, and I'll just be left with 2x. Equals, now when I do that here, one of them cancels, but I still got 2 more, because it's actually x minus 1 times x minus 1 times x minus 1. So what I got is I got a, x minus 1 times x minus 1. Here, it's b, x minus 1. 2 of them cancel in the numerator, 2 of them in the denominator, there's 1 left over. And then this one, bam, is easy, it's c. Now there's a few ways to do this, but what you want to do is come up with x values that are going to kind of make this problem pleasant, to say the least. So that's what I'm going to do. It doesn't necessarily work as well as you want it to, unfortunately, but it's okay. So I'm trying to figure out my a, b, and c. If I plug in values that will make anything associated with the a, b, or c 0, it limits down what I have to do later on. I can figure out the c very easily. Here's what I mean. If x equals, that's what I want everything to equal. If x equals 1, we can accomplish this. I'll show you. 2 times 1 is 2. Now if x equals 1, bam, that's a 0. 0 times anything else is 0. So, same thing here. You put in the 1, it gets rid of it. So, all you're left with is c. So 2 equals c. Well, that's really good. Okay. I don't have anything else I can really plug in that will cancel things out. So now what I have to do is I have to work at things. And what I mean by that is, well, now I got to figure out other x values to plug in. And what I'm going to do is I'm going to create a linear system. And with that linear system, I'm going to help try to figure out what my a and my b are. Like I said, very complex stuff in terms of algebra. I think this is an algebra 3 or pre-calculus, I'm not really sure. But, it's a precursor to more complex problems. So I want to, like speculate. I want to come up with x values that will kind of work out to make this easy. Well, unfortunately, nothing really makes it easy, but what's an x value that you think you can substitute in that's just easy to substitute in, that won't cause us so many problems? And if you said 0, that's a good pick. You can actually substitute in any x value you want, but 0 is going to make this a little bit easier. If x equals 0, what I'm left with is 0 equals 0 and 0 is -1, -1, so that's 1, so it's 1a. Or just a, plus 0, -1, so that's minus b, Don't leave this as c. I'm not going to work with another variable. That's c is actually 2. So what I get is I get negative 2 equals a minus b. Some people say, great. I have no idea what to do. No, don't feel bad yet. Let's come up with another value for x. We plugged in 1, we plugged in 0. Lots of students would say negative 1. Yeah, I don't mind negative 1, but I actually like 2 because 2 is positive and it's going to make things a little bit easier. So watch this. If x equals 2, then what I'm going to have is 4 equals, so 2 minus 1, 2 minus 1, that's 1, 1, that's a. Plus b, that's 2, that's b. Plus c, but c is actually 2. Get a and b on one side and everything else on the other. Subtract 2, subtract 2. 2 equals a plus b. I didn't do anything. I still don't get this. Well, calm down if you're at that step. Actually, what you did was you figured out something. You created a method to make this a little bit easier. What you did was you created 2 linear systems. A minus b equals negative 2. 2 linear systems. You created a linear system, that's probably the better way to say it. And a plus b equals 2. Now watch what happens. Use substitution or elimination, but in this case I'd use elimination. Take these 2 systems, and you got 2 equals a plus b, that's this one, and negative 2, different color, equals a minus b. Add them together. 0 equals 2a minus b, so the b's cancel. Divide by 2. A equals 0. How do I figure out the b? If a is 0, 0 plus what equals 2? B equals 2. There you go. You figured out your c, which is 2. You figured out your a, which is 0. And you figured out your b, which is 2. I'm going to use this piece of information to figure out what I have to do. In order to do that, though, let me just erase this so I can write it underneath what I'm supposed to. I wanted to come up with a partial fraction decomposition for this. Basically, what I wanted to do is I wanted to separate it into different fractions. In this case, it's going to be 3 fractions. Well, actually, that's not true. It's only 2. But it says, well, I got to separate it into 3 fractions. Well, let's see what happens. A is 0. 0 over x minus 1 cancels. Doesn't matter. Equals b, my b is 2, over x minus 1 squared, plus c, and my c is, where's my c? I think my c was 2. Actually, I know my c was 2, I just figured that out. Well, I should have not erased it. X minus 1 cubed. So this fraction, when I do a partial fraction decomposition, is actually this. And if you don't believe me, you can solve for this. Make sure that you can add these fractions together by multiplying this one by x minus 1. Multiplying this one by x minus 1, both on the top and the bottom, and you get 2x minus 2. The 2's cancel, so you're left with 2x over x minus 1 cubed, which is this bad boy right here. So that was an example of repeated linear factors. We're going to try one where we do some quadratics and linear at the same time. And I think I want to close it off because these partial fractions, woo, they're getting the best. Well, they're not getting the best of me, but they take a long time to do. So I hope that was helpful. Really cool, especially if you're more advanced in terms of mathematics. I hope that you found this applicable. If your math skill isn't, if you don't have good linear systems, long division, other precursor skills, you got to learn those before you end up doing these. Because this is treading on, I don't know what the saying is, but you got to tread lightly when you do this. You got to be able to know several steps, several ideas in math. With that said, have a good day for now. Goodbye.